Hi, so this is the the first hands-on video in the preparation for the workshop where we're going to consider what if building C was smart at the end of week 5. The idea with this video is we're going to jump in and start using some Python code to try and read one of the files, one of the data files that were described in the previous 2 videos. So this is the result we're looking for. Set of curves describing each of the spaces in building C, and we're going to do that with a Python component in Grasshopper. So first of all, I'm going to create a new document, and I'm going to create a panel, and in this panel we're going to store the path to the file that we want to open. So the easiest way to get that, I think, is to go to the File Explorer, which isn't open, so I'm going to open the File Explorer, go to my data. We're going to use the smallest of the 4, and in Windows I can select the file with a single click and then copy the path as a string back to the Rhino model, double click the panel, paste it in and just remove quotation marks, and there we have path to the file. Then we need a Python component. The easiest way, I think, to find that is to double click, start typing in Python, Grasshopper searches. We're going to connect our path to X. We're going to change the name of X to in file, so that's the incoming file, and we're going to specify, need to move this over here, we're going to specify that in file, the type, the object type is string, so Python knows that this is a string coming in. And then double click on Python and pull up the code editor. I'm going to delete this boilerplate for now because we're not really interested in that. And we're going to look at how to quickly open and loop through each line of a file. So we're going to create a variable called file equals open file path. What we're going to do with it, we're going to read it in commas, and we can quickly test that. No errors in the output, so we're good to continue. We can easily step through each line using a for loop with the file, and we can print each line out just to see that we're reading okay. And that looks like we're printing out lots of string data from there, so that's all good. Now we want to think about is how to make that a little bit easier to use, and one of the reasons for choosing the JSON format is we can use a built-in JSON library in Python, and we do that by writing import JSON. And so now what we can do is we can create an object which is using loads. Loads is looking for a string, which is our line, and we can test it. And then to verify that we actually have a JSON object, we can say print obj, and to access a specific attribute we use the square brackets and the name as a string, as text. So we just want the points in this case, and you can see here we're printing out an array of points. Each one of these values is an x, y, z coordinate, so that's important to remember that this data has a specific format. So now what we want to do is take those coordinates and convert it to some Rhino geometry. If we want to work with Rhino geometry, we need to import the Rhino geometry namespace and give it a short name, RG. And we're going to create a little function here called genCurve, and I'm going to pass in an object called xyz to remind myself that each value is either x, y, or z. And we're going to loop through those x, y, z values. So we're going to count with a variable called p, and we're going to use for p in range, and we're going to start from 0, step through to we reach 1 less than the length of x, y, z, and we're going to step through that data in steps of 3, because we know each one is either x, y, or z, so each time we step in 3 we know we've got a set of data to create a point. And once we've got that, we can quickly create our point by using the Rhino geometry. When we hit the dot operator, we can access the Rhino point3D object. Here we get a little prompt which is telling us different methods for creating point3D. We're going to use the first one, x, y, z, and our x, y, z here is the name of the array. P is the x value, x, y, z. P plus 1 is the y value, x, y, z. P plus 2 is the z value. And we need to store that individual point in an array, which we're going to call curve points. Define an array with an empty pair, assigning an empty pair of brackets, curve points, dot, append, and we add our point object to the curve points array. So let's just make this a bit bigger. Once we've gone through the points there, we need to come back aligned with the for loop so that we finish the for loop, and we can say, alright, our curve is a Rhino geometry NURBS curve, which we're going to use the method create, and the inputs for that are, is it periodic? It's a boolean. No, it's not periodic in our case. What is the degree of curvature? 1, to define that this is going to be polyline-like object, and then finally the points, and from the function we're going to return the curve object. So to call this gen curve, we don't really want to print the points out, but we want to create here a curve which uses gen curve, and we pass in the points, and we can quickly test this. Hopefully we've got no errors in the output. In order to return these curves to Grasshopper and Rhino, we need to say that our output A, which is the default output, which we can see here, is an array. And then every time we create one curve from a line in our file, we can say a dot append curve. Test it again. No errors. Put the mouse over A, and we can see that there are 294 polyline curves. Let's close the script editor, move this out of the way, fit the view, and we have our curves read from the JSON file.